So Askarol is going to talk today about the impacts of on-site sewage systems in the coastal areas of Texas. He's coming from Texas A&M. And you'll have two volunteers to judge this.
If I win $200, I'll share it for sure. Buy the beer. All right. This is my first time in ASAB. I'm a PhD candidate at Biological Magazine at Texas A&M. My research is not this, actually. My research, I'm a civil engineer. I do river water simulation modeling. These are my colleagues. We worked on this coastal impacts of OSSF, we call it, septic systems along the coast in Texas. And then Alice Jantrania, Dr. Jantrania is sitting way back there. If you have a hard question for me, he will be addressing those. So this is not a research project. I want to make sure I know lots of good slides that I've seen. But this is just rather identifying the problem and implementing and then fixing the problem. The OSSF in Texas, we call it on-site sewage facilities, basically anaerobic septic systems. And I'm going to give some overview, evolution of it, and then mainly I'm going to talk about, which one is the laser? Middle? Okay. I'm going to talk about this project mainly, and then some of the benefits of that, and then some solution recommendations. In Texas, we have variation of precipitation where along the coast right here, the precipitation here, annual average precipitation ranges from 45 to 60 inches per year. As you move on to the west, down to El Paso, you will receive about 8 inches per year. So these are the main problems associated with OSSFs in Texas. Soil, obviously, inadequate soil to, as you know, one side is further to the left. The treatment happens on the soil and then some undersized tanks and small property sizes. And then this is one of the problematic areas in Texas. You can see the sewage outlet just going down the neighbor's property. And then you have this as an example of a failed system. Standing water, and the drain field is broken, and then nothing is operable here. Prior to '89, Texas didn't have any sort of legislation or regulation, and then this is where the state started regulating the OSSF systems. The chart here I want to just point out, as you can see, the ATUs, the aerobic treatment units, that peaked because of after that 89 legislation, and then it dropped a bit because of housing market crash in 2008, and then now it's picking up again. So another evidence here shows that OSSFs have not been maintained so far, and then we have a lot of problems with these. And then Texas Commission on Environmental Quality is the state regulatory agency that regulates and basically enforces all the OSSF-related problems. And then that's the coastal zone in Texas, and that's divided by 16 regions, and then they operate based on the regions in Texas. How do we make it work on OSSFs? We look at main source, basically water, hydraulic load coming from the house, and then we determine the soil conditions, if the soil is fit to treat further treat the wastewater, and then we do some designs and then implementation with installations. This is just a quick overview of what it is. It's basically, we call it two-compartment tank, and then hydraulic load comes in, and then wastewater stays here, the sludge settles down, and then you have scum layers here, oil and grease, and then the water goes through the perforated by further treatment. This is the aerobic system, where you have a constant aerator pushing the air, aerating in microbes to treat the waste with the clarifier, and then from there the pump tank that tanks the water for the treatment in the soil. And then operation, aerobic systems are high maintained systems for homeowners, especially because of the chlorination, aeration, electricity, and pumps, a lot of things involved in it. It's pretty high tech. This is one of those things we say do not do, because you can't spray to the kids' playground. That's not a treated water yet. It's partially treated. And in Texas, we designate them purple pipe means don't drink that water, so replace the water. This is the subsurface drip distribution system. Is an example when the water pump pumps the water back to the drip field. This is a schematic representation. And this is one of the test sites, one of the projects we've done, construction out of 21 systems we've installed. And you can see the uniformity of the drip lines. Before we test everything before we put them in. And then this is after a few months after we have them. You can see it on the background, the coastal water. This is a limited property, a real small size of property. And let's talk about the project. The project is sponsored by TCEQ and Texas Land Office and also EPA. And then we started this back in 2010. Primary reason was you look at any non-point source pollution papers, and the majority of them reference failed OSSFs, failed septic systems. So we wanted to kind of go in there and then sort of try to fix this problem. And then there are three components, major components of the project. We educate the public first, and then we do inspection of pump outs for them, and then replace some of the failed systems. The public outreach program is, we developed the 2-hour fundamentals of OSSF class for homeowners. We train them how it is, how it works, what it does, what are the benefits, what the benefits are. These are some of the results that homeowners are willing to adopt these kind of the practices, and then we get knowledge we give them. This project is volunteer-based. Based on, after we provide the classes, we give them evaluation form telling us about their septic system. We incentivize them by providing free pump outs and possibly replacement. That's how we approached this project. It was very successful. There's no enforcement. We're not an enforcing agency. We just go out and based on a volunteer base. And for the pump out inspections, this is Ryan Gerlich, a co-worker of mine. He is a pipe whisperer. As you can see, with the probes, we identify the pipes where they go, inlet and outlets. This is me. That's what the majority of the grad students do, besides talking and dressing up like this. We dig up some of the tanks. We prepare for the contractors to come in and pump it out for us. During the inspection, we do samples. We measure the samples inside the tank, and then all of the other works are handled by our contractors. And then part of the continuous education, we provide, we get homeowners involved. Ryan Gerlich here, I'm the photographer, luckily. So, and then this is a pumping out process, and that's a homeowner. We're explaining to him how the inlet outlet vessels, if they are missing or some problems, continuous education. And then here, we are abandoning the tank, the broken tank, the system, failed system, and constructing a new one. That is the sprinkler for that system. And then right here, you can see the gulf, that's water right there. And then that's the tank. You can see the lid, the whole lid. That tells you a couple of things. This tank is more than 30 years old because way back then, that's how they put a concrete tanks. You don't have little the lids like this here for pump out. And also what we realized on this one is way back then they just punctured the bottom of the tank too. That was buoyancy, anti-buoyancy theory. We discovered those too. So this is the typical example of failed system when septic system was installed and they built a home on top of it. So this has been going on for the last at least 20 years, and there were 5 people living in there and 8 cats. So then like this, it's just a walk-in sewage. We were able, luckily, to replace the whole thing for the homeowner, built a new one, which was the most expensive project. We spent about $35,000 on it. So this is the example of the small tank size. So you can see the home. This is a 3-bedroom home in state of Texas. We require at least 350,000 gallon tank for 3-bedroom homes, but this is 250 gallons. That tells you how old that is. Then you can see here, missing reinforcement. So over the time, we tell the homeowners that lid over the time that the reinforcement corrodes. That's a perfect example that it's going to fall in, so you're going to have to replace. And it's another aspect. There are a lot of research going on right now identifying why causes. So I'm not going to go into detail on that. Some of just the results of that inspections, you can see 46 of the system out of 75 were older than 89. So, and then here, different ages, different volumes of the tank. And then these are the, actually we measure all of these before the pump out is performed. So then about when you reach 1/3 of the tank capacity, you have to pump. So we recommend usually 3 to 5 years, every 3 to 5 years. With the conventional system, we're talking about anaerobic, just aseptic tanks. This is not a blood, actually, it's a dye test. It's one of those things we do when a homeowner has backflow in their bathrooms and stuff, and then we go in identifying where this is going to make sure that there's a leak. We do that kind of test too. As you can see, inlet baffle is missing, which impedes the hydraulic load from disturbance. And then this is the tank I was talking about earlier. So there's you can't see that right now. There's a puncture or hole. That's how they dealt back then. Anti-buoyancy. As you know, the Gulf is seasonal water tables that are 2 inches of water, and then swell shrinks, and then you have, if you don't fill up the tank or heavy tank, you are in trouble. Tank pops up. So the baffles, as I said, in 67% of this, the 75 systems we analyzed and inspected, they were inoperable. Site evaluation is basically soil. As I said, soil is the main component of the whole treatment unit. And you can see here in the picture that water, seasonal water table, the 18 inches that deep in that Gulf. This is clay soil. And then we have contractors to do that for us, and then we have engineering designs examples. They do all that, and then they provide engineering designs. We evaluate them and then choose. And then this is the replacement systems. We've replaced 20 of those systems so far. And then you can see the drip tubes. That's how our contractors are doing, laying out. These are the real pictures from the 21 systems we've done. And then part of the project requirement was to calculate potential the hydraulic load, the pollution. You can see we followed the equation by EPA manual. This was recommended us to do that calculation. As you can see that this is the new treatment efficiency system that we're talking about, the systems we would put in. And then we just estimated how much of that has been reduced, reaching the goal through the project. Conclusion. Training is the main component of that and very critical part. You know, one of the challenges was, okay, we got the money, how are we going to do this? So then we said, well, we're going to go to homeowners, set up training classes, and then we're asking volunteer base. This was the key to success, because as soon as you see a TCEQ, they go away. So, you know, in Texas, you don't go to properties or somebody, evaluate stuff. It's Texas. So we were very successful because of that education, and then from there on, purely volunteer-based approach. Recommendations, obviously, one of the things we came across was there's no unique database system about OSSF permitting. So each county has their own system, like spreadsheet or based or some other, but most of them are on papers. You don't have digital ones. So we were recommending to build some sort of a database so everybody can see and